today we want to investigate variables and how we use those variables with our Arduino, and we're going to do that using the TinkerCAD circuit simulator. So we're going to need a circuit to simulate, right? So let's go look at our Arduino setup options. Let's maybe get a, what do I want? I'm just going to go get a breadboard setup for now. So we are using your Spark Fun Inventors kit. And so in that kit, you have a setup like this one, right? You have your Arduino board down here, you have your breadboard up here, and we can connect stuff to it. That's what we're going to do. Let's see, what shall we connect to it? I'm going to start with a button because buttons are useful. Why not have a button? So if we're connecting a button, we're going to remember all the things that we need to connect it. Let's see, so one side is going to go through this nice high resistor. So I changed the value there to one of the ones that comes in your kit, the 10K. That's the one that goes brown, black, orange with gold at the end. And then I'm going to connect this other side to ground. And then I'm going to connect this side, the same side that went to power through the resistor, to a port on the board. It can be a digital port because a button is a digital sensor. So I'm going to connect it here to port 12. Before I do anything else, I'm going to go over to my code section. We're working in text, so I'm going to do that. I'm going to set up a header. And let's see, today's date. Oh my gosh, guys, it's almost the end of March. That's kind of crazy. Demo for using variables in Arduino. Cool. So one of the first places that I'm going to encourage you to use variables is when you're setting up your components. In this case, I'm setting up a button. So I'm going to say int for integer. It means a number, a whole number. And I'm going to call this button pin. When I set up variable names, they have to have no spaces. So kind of all squished together. Now, does it have to be button pin? No, I could name this flamingo. I could name this my favorite color is purple. All of those would be acceptable variable names, but they're not helpful variable names. We really should be able to tell something about what a variable is doing just by knowing its name. So here, the name button pin is descriptive of what that variable is going to hold, because I am going to tell it that I am going to save the number 12 in that variable box so that I can use it anytime in my program now, and it will know that it is number 12. And if I need to move where my button is connected to a different pin, I will only have to change this line 7 to update my whole program. Okay, so that's why we do it. So you might notice that I have a capital P here in the middle. That's just to make it easier to read, right? If we start all in lowercase and we have an uppercase there, when I change words, it just makes it easier for your eye to kind of pick out where the words are changing from one to the next. Again, not required, but good convention. We want to make these programs readable for yourself, for your teacher, for your future self when you refer back to this a year from now, because you're like, oh, I wrote a program like that once. I'm going to go find that. Oh, I can't read that. What the heck? Why would I name a variable flamingo? That wasn't a good idea. Don't do that. Okay? Be nice to your future self and nice to your teacher. So here we have this variable button pin storing the number 12. So now in our setup section, instead of a particular number, we tell it button pin. And a button is a sensor, a type of input. We're taking in information from the outside world, right? When a user presses that button, we're taking in the information that they have pressed that button. Okay, here's that flashing code. We don't want that. Instead, we are going to set up serial monitor. So that we can have a program that just checks and makes sure it's printing okay. So a button is a digital sensor, so that is a digital read. And where am I going to read? I'm going to read the button pin. Now I don't need those numbers anymore. Okay, should be everything we need to start our simulation. Hit start. We can see in the serial monitor right now that it is giving a 1. If I press the button, it switches to a 0. Okay, so our code is communicating to the board correctly. Our button is attached correctly, and it is sensing reliably. All good things to check. Okay, now, so that was kind of our first way that we might use variables. So for example, if I decided, okay, I'm gonna now have this button attached to pin 13, instead of going through everywhere in the program that needs to be changed, I only have to change it right here. And it'll work. It won't work. What did I do wrong, guys? Button pin. No, it's good. 13 of button pin, button pin. Well, actually, I'm not sure that 13 can be an input. Okay, we're back to working there. Love it when I say that something will definitely work and then it immediately doesn't. Really does excellent things for my credibility. I'm kidding. You run into problems all the time. You have to be willing to roll with it. Hey, there we go. I'm pretty sure that 13 is just set up to be an output only because it is wired to that little LED check light there. Because here we go, 11 is working just fine. Okay, there you go. We have a functioning button. Cool, so now the next thing we might want to do is add another part. Let's go add another part. So I'm gonna close my code and I'm gonna go look for a new part. Maybe something we haven't done before or recently. Oh yeah, let's play with the RGB LED. That's fun. I like this thing. Pretty colors. Okay. So if you kind of hover over these legs here, are red, blue is here, green is here, cathode, right? There's that one. That's the one that we're going to send to ground. Good. And then these are the ones that we're going to send to the board. Now you have options here. You could have these share a resistor like this. And we use the 330, not 330K, just 330 from your kit. That is orange, orange, brown, and at the end. And you could put that on the shared cathode here, or you could give these each their own resistor if you wanted to be able to have different resistor amounts for the different paths. I don't think I'm going to do that today. What I do know is that I want all 3 of these legs to have a connection to the board, and I want all 3 to have a pulse width modulation connection to the board, right? One of those ones with the little wavy line in front of it, so that I can send different values. So here I'm going to do that. Number 6. I'm going to make that one red. This one is blue. So I'm going to go to number 5, and I'll make that one blue. Like I have a question. One sec, folks. There, that one's green. So I'm going to send that one to green. And hey, look, it's already green. Isn't that handy? Go back and do some good color coding while I'm at it. Okay. If you put a resistor on the power breadboard, you will never have to do that. You're right and you're wrong. So if you changed if you protected everything with the same resistor, you're right. But maybe I don't want everything to have the same resistor. For example, I don't want my light and my button to have the same resistor. I want this one to have a fairly low 330 and this one to have a much higher 10K. So most of the time it's not in your best interest to protect the whole breadboard with a resistor because you want to be able to control components separately. Okay, let's go back to our code. And we are going to set up some more variables up here. So I'm going to have red 6, blue B5, and green B3. I also need pin mode for all 3 of those now. But instead of button pin, they have their color names, and that is not an input, that is an output, because we want to tell the LED what to do. We don't want to read what's going on the LED. We want to tell the LED what it should look like. Okay? Red, green, blue. Okay, before I do anything else, I am going to check to make sure that those are working. So how could I do that? I could do that to start with. I could do a digital write, red to high. Oh my gosh, I cannot like type and talk at the same time. Really not good at that. Okay, we're gonna delay. Do red, green, blue. Low. Let's see. Before, no, after the delay. And okay, red, red, green, green, blue, blue. So hopefully I did all that right. We should turn on the red light, wait, and turn it off and turn on green, wait, turn off green, turn on blue, wait, turn off blue, and then it'll repeat. Let's make sure we've wired up our LED correctly. Nope. What did we do wrong? Green. Didn't I have one? Oh, I forgot the int in front of the green, guys. Where were you on that? Okay. So you can see here that when we have an error, it does its best to localize it for you. A lot of times, if you go to the top stripe of orange and look upstream a little bit, you can find out what's wrong. In addition, right here, it said, hey, green is not a thing. What were you trying to do there? And so I went and looked where green started, and it was true. I had forgotten the int in front, so it didn't know what green was. My fault. I tried to tell it, I should have told it that it was a variable, and now I have. Okay, let's try again. There we go. Red, green, blue, red, green, blue, red, green, blue, hooray! Okay, our button is working correctly. Our light is working correctly. Let's use some other stuff now to demonstrate variables. Okay, so I'm gonna start with what is something that might be useful. I'm going to set up a variable called button presses. And I'm going to start it at 0. because when I start the program, I won't have pressed the button at all. Okay, good, I like it. And now down here in my code, I don't actually want this stuff anymore. I'm gonna get rid of that. I am going to start by just checking if I have pressed the button. And if I have, I'm going to count. So this will let me count how many times I have pressed the button. So if, because I'm going to make a choice, either I have pressed the button or I haven't pressed the button. If, and now we want to get information from the button. That's digital read. And where do I want to digital read? On the button pin. And if it is a 0, that's how I know that it's been pressed, right? Okay. So if we remember from running the serial print, it's 1 when it's not being pressed, it's 0 when it is being pressed. This is how we check for a button press then. If digital read on the button pin, 2 equals means I'm checking to see if 2 things are the same, like balanced, right? The single equals up here is I'm telling button pin, hey, you're now the number 11. I said so and it's true. That's an assignment, right? Whereas down here, the 2 equal signs means I'm checking to see if these 2 things are the same. I think of it like a balance, like a scale. It's 2 things. And that's how I remember. Okay, so what do I want to happen if I press the button? Well, I think I want to keep track of it in that handy button presses variable I set up. So I'm going to go look at button presses, and I'm going to assign it to whatever it is right now, plus 1. So here, line 27, what is this line going to do? It is going to, if I have pressed the button, find out what button presses is right now, which it will start out at 0, and it will add 1 to that and save it back into button presses. Okay, so now up here on my serial print line, instead of reading whether or not the button is being pressed, I am going to have it print out how many times it has been pressed. So when I start the program, this should be 0. And the first time I press the button, it should become 1. And the second time, it should become 2, etc. This that I'm about to run is not going to work well, but I want you to see why it doesn't work well. Okay, we're going to start it. We're going to go look at the serial monitor. Okay, reading 0. That part's correct. I'm going to come over here and press the button, and we're going to see what happens. Oh my gosh, I went all the way up to 26. I didn't press it 26 times, I promise. I'm going to try again. Oh my gosh, I made it all the way up to 44. This is not going well. If we scroll, so I've stopped the simulation. Now, if I scroll back in the serial monitor, go all the way to the top. Far as back as I can go anyway. So here's all the 26s. Oh, and then see 27, 28, 29, 30, 31, 32. It just went really, really fast. Your Arduino runs really, really fast. It may not always seem like that in the simulation that we have here in TinkerCAD. Sometimes it's quick, sometimes it's not. Sometimes it depends on your internet connection. But Arduinos themselves run really fast. So I can't let go of the button fast enough. Instead, I need to put a little delay in here and say, whoa, Arduino, can you slow down and wait for my poor human reactions to catch up with you? I'm going to give it half a second. Probably more than you need. Usually a like 10th of a second. So 100 milliseconds usually does it, but let's just do this for now. I'm going to clear the serial monitor so we can start fresh. Okay, so 0 is what we're getting. Now, press the button. 1, good. Press the button. 2, excellent. Press the button. 3. It is now counting the actual number of times I pressed the button, not how many milliseconds I've pressed the button for. Okay, so this is now working reliably. Hooray! I'm gonna stop. Okay, so what else could we do with this information? Let's let this number of button presses affect something in our LED. Yeah, let's do something like that. This will be fun. Let's see. So first, I'm pretty sure that 100 milliseconds will be just fine instead of 500. So let's test that and see if 100 is about right. So there's 0, 1, 2, 3. Okay, that's working pretty well. I'm going to go with 100 milliseconds. Okay, so what do we want to happen when I press this button? Let's think. Let's do something with our light. So I'm going to this time analog right red and some number. What it's going to want to look like is we need to decide on a number to go in here. So let's do something like button presses times 10. So it's kind of cool that since button presses is a number, we can do a calculation to it and put it right there in that command spot in analog right. So now line 28 here says, I want to analog right, so send some sort of signal. Where do I want to send it? I want to send it to the red part of the RGB LED. That's on pin 6. I know that because I set that up here. And what signal do I want to send it? Well, go find out how many times I've pressed the button and multiply that by 10. So at the very beginning of the program, 0 times 10 is 0. So this will be off. And then as I press the button, the red should get brighter. Let's give it a shot. So right now our program is running. The red is indeed off. Oh, so that should be 10, right? Because I pressed the button 1 time. And it's starting to get more red as I click the button. Now we're going to reach a spot where we've kind of maxed it out because 255 is the highest it can take. So when we hit 25, that's pretty much as red as it can get. Can you make the serial monitor reset to 0 after a certain amount of button presses? Absolutely. Yeah, you want to do that? Let's do that. So it's less about the serial monitor. What you probably want is this to reset to 0 once I've reached like 25, because that's as high as I can go, right? So sure, let's do that. So I'm going to add an if statement. Let's give it something else to check as well. If button presses is more than 25, what should happen? Let's set it back to 0 and start over again. So this will let it, we're going to test it out here in just a second. So this part will count up each button press. And this part will make light more red with each button press. And then this part down here will reset button presses to 0 after 25. All right, so I'm going to clear out the serial monitor. I'm going to start the simulation and let's take a look. So we're at 0 right now. And 0 times 10 is 0, so we have no red light. And I'm going to start pressing it. There's our 1. We can see it getting more and more red. 24, 25. Okay, so what should happen in just a moment is that I will click it. It will become 26, but at the moment it becomes 26, this line right here will say, hey, wait, now button presses is more than 25, so I would like you to reset it to 0, please. There we go, and we're back to 0. And counting up again. Ta-da! Okay, I think that's kind of the question you had in mind. Now we could certainly also, we could add another button that could control the other colors. Let's just try turning on blue, at least part way, so you can kind of look at color mixing. How about that? Blue, and let's give it like 100, probably plenty. So now this line says, hey, turn on blue. There's nothing in here, anywhere in the program, that will turn off blue or turn it up or down. So blue will remain 100 all the time. And we're just going to change the amount of red we're mixing with it. Okay, so all blue. And we can see it start to turn purple. But and as I'm adding more and more red, we're getting kind of violet, pinkish, and then now we're trending more towards a very reddish, pinkish, and back to blue. Okay, good way to experiment with color mixing. All right, stop simulation. Let's see, what else might I like us to be able to do with variables today? That's a pretty good place to be in half an hour. So we have used them to track pins, like our button pin and our red, blue, and green pins on our RGB LED. We're also counting up the number of button presses using this button presses variable. And we're using it in a couple of places. We're using it to decide what to print in the serial monitor. We are counting up our number of button presses as we go, and we're using it to count and reset, so we can kind of cycle through and go back to the beginning on counting up increments in color. So that is several things that now we know how to do. I am going to pause there and take questions.